Good evening, everyone. Welcome to Island Issues. I'm Jerry Lyons, your host for this evening's program. And tonight on our program, we'll be taking a look into the future of space travel. For the past 2 weeks, we've been hearing a lot about space, specifically the planet Saturn and her moons from the Voyager space probe. But coming up soon, another NASA project that promises to be one that will transform the way we look at space and space travel. On March 14th, 1981, the Space Shuttle will be taking off from Cape Canaveral on its first mission. The Space Shuttle is NASA's biggest project. The answer to the question, what can the space agency come up with to make space travel routine and make the very costly process of putting satellites into space less expensive? The Space Transport System, as it's called, is composed of the part airplane, part spaceship called the orbiter, where the crew and the mission specialists will guide the ship and conduct experiments in space. The propeller tank, which holds the fuel, and the 2 rocket boosters used to thrust the shuttle into the sky. All parts of the system are reusable, except for the propellant tank. The unique aspect of the orbiter is that it can be launched like a rocket at the pad, carry out its tasks, and be guided back to Earth, landing its crew, like a plane, on the specially constructed runways built by NASA. When the shuttle makes its voyage in March, the NASA tracking station here on Guam will be playing a very vital role in the safe landing of the shuttle as it plans its touchdown at Edwards Air Base in California. And in tonight's program, we'll be talking to 2 of the astronauts who will be on a future mission of the Space Shuttle and asking them about the role that Guam will be playing in their mission. My guests tonight are Major Ellison Onizuka. Thank you for joining us, sir. And Commander Jon McBride, who will be the pilot of the shuttle. Gentlemen, welcome to Island Issues, and thank you for coming to see us. I know that all week you've been visiting everybody on the island, the guests of Gov Guam, and thank you for making time for us. Major, let's begin with you, if you would please. Tell us briefly why the shuttle was designed the way it was, the aim of it, the purpose it was constructed, and what kind of projects it'll be carrying out.
The shuttle was designed as a reusable spacecraft for this country, which would essentially allow us to reduce the cost of putting payloads into orbit by a factor of 10. With this reusable shuttle, which launches like a rocket, lands like an airplane, we're now able to recycle the spacecraft. Our plans are to use the shuttle 100 times prior to complete refurbishment.
And this, of course, was done for cost and also to make things easier to put into space. I think there were some figures that said that $500 million or more might be saved when the operation is fully complete. I think there were 4 shuttles altogether that are planned.
They're designed to build 4, yes, that's the plan.
Okay. Commander, currently there are about 35 men and women who are pilots, mission specialists, scientists involved in the Space Shuttle project. According to information we have from NASA, there is a possibility that civilian pilots may soon be used in the shuttle. Why the change? Years ago, if you wanted to be an astronaut, you had to go through years and decades almost of training, and now all of a sudden the requirements seem to be coming down a bit. Why is that?
We do have civilian pilots right now. That's I don't know whether you got that information, but we have a civilian pilot that came on board with us, but he did have military background. I think, as a matter of fact, all the pilots do have some sort of a military background, the ones that have flown before, and that's seems to be a necessity because that's about the only place that you can get the high-performance jet time that's required to get into the Space Shuttle program or the astronaut program up to date.
Now, you've been a pilot in the Navy. Is the shuttle easier to use, let's say, than planes before it, or do the computers take care of most of it?
No, I think it's a combination of both. It's not an easy airplane to fly as some, but it's more difficult than others. It's somewhere in the middle there. The computer, like you say, does do a lot of the work for you. Ultimately and ideally, once we get the system full operational, from the takeoff to the landing could be all automatic, and the pilot would do nothing but sit there and monitor everything.
Let them do the driving.
We don't like it, but that's the way it is.
Major, you and the commander have been going to the NASA station here on Guam, briefing the crews there. Tell us a little bit about your briefing and the role that Guam station will be playing in the shuttle project.
Well, our briefings were set up primarily to educate them on their role in the shuttle program, and at the same time to re-emphasize the fact that the Guam station is a very important station to us in the initial orbital flight test for the Space Shuttle. For the first flight, the Guam station will acquire signal with the shuttle orbiter at about the 6-hour point into the mission, and continue to help us update the various systems on the orbiter with uplinks of data and also picking up data coming down on a downlink. However, I think the most important pass that the Guam station will support us on will be the last and final pass, and that is when the orbiter makes its deorbit burn over Australia. It'll be picked up by Guam as the first station that the orbiter will see. Guam will then relay the data to help us determine whether we got a good burn, whether we're on track to Edwards Air Force Base in California. In the event that we are not on track, we can make a last update of our state vector, realign the shuttle vehicle, and be back on track to Edwards Air Force Base. Essentially, it's the first station to pick us up after we make the full commitment for an entry. That's a deorbit burn. And it's the last station that can help us prior to the landing. It's a very important station for us, and our task here was to work with the personnel at the station and to relay this message to them, also to educate them on the shuttle program. It was a mutual thing. I think they educated us on what the state-end stations do, and I think both parties learned a lot. We certainly did.
In case, well, you'll be the pilot commander, in case there is some problem with it and you're not able to make the re-entry to Edwards Air Force Base, what are the alternatives you'll have? NASA, I think, built some runways or sanctioned some runways for emergency landings for the Space Shuttle craft. Where would you have to go then?
Well, if the landing is planned to go into Edwards, we do have a contingency site for an underburn. That is, if you don't burn enough and you end up, your trajectory is long, you would go into White Sands, New Mexico, and land at Northrop Strip, which we cleared off there in the middle of the gypsum salts, and land there. As far as coming up short, like you well know, Edwards is near the ocean there, so if you come up short, you're going to be in trouble.
You mean, does the shuttle float now?
No, it doesn't float very well.
Okay.
So that's why the pass over Guam is very important.
What will you be doing? Will the satellite dish be picking up your voices? Will it be picking up blips from the communication systems on board the orbiter? What kind of information?
Both the air-to-ground voice, the pilots, and talking to the ground, and also downlinks and uplinks data via microwave into the system.
And passes the information
Right.
off to Goddard?
It's a two-way street. Information from us via data link to Goddard, and from Goddard back to us.
Okay. What spin-off technology, Commander? Perhaps you're a little acquainted with it. Whenever NASA has a project, they have a certain goal, and as a result of the technology or the science or the experiments involved, there are always some side benefits from it. I think in the information from the shuttle, scientists working on that particular orbiter or the particular space transport systems have come up with communications, medical breakthroughs that they probably would not have found had they not taken that route. Can you tell us a little bit about some of the breakthroughs?
Some of the breakthroughs that I'm looking forward to personally, as you well know, one of these days we're going to deplete our energy, our fossil fuel sources. So it's very interesting to me that we use space to come up with a new alternative for the fossil fuels here on Earth. And I think about the only answers are nuclear energy here on Earth or solar energy that we go out and collect out there and beam down to Earth. So it's very important and very interesting to me, and I want to become involved in the missions that one of these days I hope we'll go up there and build solar power stations to beam this energy back to Earth.
Along that line of construction in space, I think it was mentioned in the information that I read that the orbiter or the shuttle can be used as a means to an end. It may not be necessarily a goal that NASA worked for without other goals being behind it. What kind of construction or orbiting satellites or laboratories can the shuttle begin making in the mid-90s?
Well, in the mid-90s, we're looking forward to large space structures on the order of solar power satellite that Jon just mentioned. We're looking toward building orbiting space stations or Space Operations Center, as we refer to it at NASA. And what it is basically a modularized concept where we would take various modules in the payload bay of the orbiter up into space and link them up together. Eventually, with a large orbiting space station like that, we could start to look beyond the era of the shuttle into mining of the moon, maybe, or another interplanetary mission, and probably the industrialization of space, which is going to be a big breakthrough for industry, for the people here on Earth. I think there's a lot that can come with the program.
Now, there's a project that NASA is working on called the Space Lab, which apparently seems to be components that can be hooked together in a number of configurations. A laboratory in space. It has a pallet, it has a laboratory, it has facilities for people who will be working in space. Will you be taking the Space Lab up with you, or any?
Yes, the
parts
Space
of it?
Lab will go up very early in the shuttle program. It's being built by 13 participating countries from Europe. It's primarily developed to do scientific experiments in the area of medicine, astronomy, and the engineering sciences. The Space Lab can be put into various configurations by linking modules. We could also attach pallets as part of the Space Lab payload. Essentially, it allows us the option of reconfiguring the Space Lab payload with modules and pallets, or just modules alone, depending on what the experiments are.
And scientists could live there and carry out experiments.
Only for the time that the shuttle is there, because the Space Lab, bear in mind, does not get left out there in space. Space Lab is a module that's carried in the payload bay of the orbiter. We take it up into low Earth orbit, and we stay there for some 7 to 30 days, and return with the Space Lab intact, still attached in the payload bay of the orbiter.
Okay. Continuing that theme of the payloads, the types of missions that the shuttle will be bringing to outer space. At the press conference that we had when you first arrived here, somebody mentioned the fact, well, we've got nuclear waste here, and what about shoving it in the payload and blasting it off into the middle of outer space? Is it feasible? A lot of experiments, a lot of things that are being talked about the shuttle are left wide open. Possibilities are endless. Is there a possibility?
Well, that's a great possibility to use the shuttle for, but you got to consider the cost of doing something like that. To take a 55-gallon drum, for instance, and probably weigh 500 pounds, to take it out into orbit and eject it out of our solar system would cost millions and millions of dollars. It is a viable alternative, and probably as we get more operational, it'll be more feasible to do something like that.
Speaking of the shuttle's capacity to make a transition, one of the things that NASA has been saying is that it's very valuable because it can go from spacecraft to airplane and then back and forth 100 times or more and be used. Psychologically speaking, are either of you gentlemen a little bit worried about the kind of effect that'll have on yourselves? It's one thing to go into space, it's another thing to have to make such a quick transition. Astronauts in the past have had various effects from taking a view of the Earth so many thousands of miles away. How are you geared for that? How are you prepared for that?
I think by the time that I've gone through an intensive training program for my specific flight to get climbing that thing and light it off and go do it, I think I'll be fully prepared and ready and anxious to do it. Of course, there's that little bit of anticipation, and probably in the back of your mind there's probably some twinge of fear that like everybody has that's flown high-performance jets or been in combat, but I'm looking forward to it, and I think by the time that I get in the cockpit and we're ready to go, that everybody else that's been instrumental in the program is going to be ready too, and I'll have all the confidence in the world in them and the system, and have no qualms about doing it.
You'll both be, of course, making a round-the-world trip, I believe, to a lot of the NASA tracking stations that will be involved in the Space Shuttle flight. Is that true?
Not us personally. We had the good fortune of visiting the tracking stations here on Guam, and we're going back to Hawaii to visit that tracking station. But we've had 3 sets of other astronauts visit our tracking stations in Australia and South America and in Europe and the Indian Ocean.
Now, the 2 astronauts that will be going on the first flight in March are Young and Crippen, correct?
That's right.
Are they training now, or are they visiting the tracking stations too, or undergoing tests?
No, the visits to the tracking stations are being done by the support crew. The prime crew, who are Jon Young and Bob Crippen, are in training right now, and they have been training for the last 2 years with very intense training, preparing them for their first flight.
Okay. It's very difficult for them to leave the training cycle right now. It's difficult for them to find a few hours to leave Houston or the Cape or something. They're really involved with the last-minute preparations.
How many years in advance did you have to begin training in order to be at the stage that you are now?
We've been with NASA a little over 2 years. We were selected in January of '78 and reported in July of '78, and we went through a 1-year intensive sort of a candidacy period. And then we were dubbed astronauts after that year. and considered qualified for an assignment to a flight. And we have yet to be assigned to a particular flight number, and about the earliest that either of us could fly would be number 5 or 6.
I see. Do you know what you'll be taking with you on your flight? I know that you were requested to be bringing our Miss World, Kimberly Santos, in picture form, of course, up with you in space.
Unfortunately.
Yeah, I know. Well, you'll have to talk to Goddard about that one. But I know that there's a long tradition of presidents and leaders in the country of asking you to bring objects with you in space. Are you allowed to bring souvenirs or things of that manner with you?
You're allowed to take a certain amount of small mementos and things. I think most of the guys take American flags and things like that, and pictures of Kimberly Santos and stuff like that. But we're allowed a certain amount of private and personal little articles to take with us.
Are you,
within reason.
Oh, sure. Are you worried, though, about, let us say, in the actual mission itself, so much could go wrong. You've been trained for so many contingencies. The computers do take a lot into account. I read that there are a series of computers, and sometimes if one makes a decision that varies from the others, it's voted down electronically. They don't even listen to those signals. Are you satisfied that the voyage you'll be making will be safe, will be problem-free, or are you still working out the bugs along with NASA?
I think we all need to accept some risks. Both of us have come from a background in flight testing. We have sort of become accustomed to that. Yet, granted, there are a lot of risks with the Space Shuttle or any new program. However, when we start to assess the risks involved and look at the challenge that lies ahead for us, it certainly outweighs the risk that we have, and I think we accept the challenge more than we were about the risk.
You've got to consider this as just another developmental type aircraft situation, really. That's what it is, and we both, I think, Ellison will go along with this. You just don't go through an aircraft development phase without having certain problems. And I don't think anybody can come up with any aircraft that was ever designed and built and tested that didn't have any problems. So I'm sure along the way there are going to be a few, and I feel confident we'll get them ironed out like we always have.
Okay. And we'll be back in a moment right after this break. More Island Issues. We're back now with Island Issues. We're speaking to two of the men who will be taking the Space Shuttle into space after the first shuttle launching is in March of 1981. My guests this evening are Ellison Onizuka, astronaut, and pilot and commander of the craft, Jon McBride. Gentlemen, we were talking a little bit about the Space Shuttle before, some of the experiments that will be carrying out, some of the payloads that you'll be bringing with you. One of the problems that we have here on Guam and the Pacific, of course, is storms. Advanced weather tracking helps us a lot to prepare for it, to know when and if the storm will veer off course or hit us. When you go, or when your colleagues go in the Space Shuttle, you'll be bringing satellites to be left out in space. Will any of these satellites help us here as far as tracking weather, preparing for storms?
Definitely. Satellites like the GOES satellite that was just launched recently on a Delta system are used for weather data, and we will be carrying the next generation of GOES spacecraft on the shuttle, along with other weather satellites which are presently on the drawing board. We'd definitely be able to help in a situation like that, because we'd be able to present data that would tell you which way the typhoon or the storm is moving. It's a great tool for tracking of storms, hurricanes, just about anything you can name with the weather. We can also start to predict when we're coming up on a drought, things like this.
Well, currently we use satellite pictures here in the forecasts of our weather. Will these pictures from these newer satellites be quicker, easier to get at greater intervals?
It probably will be, but we've almost reached the state of art as far as, actually seeing things here on Earth and predicting and things like that. We can't do much about it. We can predict it and tell you it's coming and everything, but the only thing we can't do right now is do anything about it.
We can refine it and maybe get it to you a little bit faster, give you a little more clarity, and essentially give you a better picture. When you start to look at the technology that's there on some of the satellites, navigation, for instance, we can now pinpoint a ship's accuracy or aircraft accuracy within 50 feet using these satellites. And we're finding it much more when you're looking at something like this from 20,000 miles. Isn't going to do us very much. I think, you know, we're going to gain very little if we were to refine that down to, say, 10 feet.
One of the things that NASA has been criticized in the past is the amount of money. When people went to the moon 11 years ago, they said, why use all that money to send a craft to the moon and come back instead of spending it on some of the problems we have here on Earth? In the book that I used partly for research by Howard Alloway, who works for NASA, he says that critics of NASA who say that the billions of dollars used for the space transport system, the system you'll be using, should have been used on Earth. He says they're wrong. Critics are wrong because the numbers of people that the shuttle has put in jobs has helped stimulate the economy. Give us a little bit about that side of it. How many people have really been helped or benefited indirectly by the shuttle project?
Well, the space program has not, certainly not put people out of work. You know, everybody has said all that money spent in space, but that money was actually spent here in our own American economy, paying for the salaries of the hard-working Americans who helped put the space program where it's at. When you start to look at costs, you know, it's pretty hard to measure human values against dollars, but in recent years, you know, as late as 1979, the HAW spent NASA's budget in every 8 3/4 days. You know, when you start to compare NASA's budget with some of the other departments that we have, certainly it's not a lot. However, I think the visibility that NASA has had with the space program has certainly brought on some of those criticisms that we've received. If we should go back and look at the spin-offs from the space program, I think people would start to appreciate what the space program has done for this country and the rest of the world and what we can do with it. An economist once said that for every dollar we invested in the Apollo program, we returned $14. So
From all
that's
the
a very
benefits
good
for
I'd
return.
like to comment a little bit on that. You know, even if I'm biased, you know, and kind of prejudiced because of my position, but even if I weren't where I am now, it'd be very difficult for me to sit back and say, we gained nothing out of the space program. You know, it's, like you said, the 14-fold return. You know, the communication that you and I are talking over now and things that are beamed to you here in Guam, it's all spin-offs of the space program. Some of the food processing techniques, all the modern-day microprocessors and computers and electronics, it's all spin-offs of the space program, and it's very difficult for someone, I think, to sit down and say that our money is well as wasted, not used in a proper fashion. NASA's budget is less than 1% of the total national budget, 1%.
Is this a few $billion?
I think next year it's 3.8 billion.
And the shuttle project is how much of that? Is that a major part
The
of it?
shuttle's the major, that's NASA's major project right now. It's probably, I don't know numbers very accurately, but maybe 80–90% of that.
Well, the Department of Defense considers it a good project, a good investment, because they'd like to send some payloads along in the cargo hold. What kind of Department of Defense projects are we talking about? Would these be satellites to monitor that could be used, let's say, in the SALT II treaty to make sure that people are not using missiles?
That's what we're looking at right now. You know, if we were to ratify something like the SALT II, then a surveillance-type satellite would be about the only means that we could ensure that the signed parties were validating their part of that treaty.
Well, one of the problems that you've been having with the shuttle, of course, is the tile construction. I think there were delays for weeks or months because of the certain tiles that had to be put on the underbelly of the orbiter to keep it from burning up when it reapproaches the Earth's atmosphere. How much of these delays, let's say, added to the cost or set you back?
I think each delay has set us back. When you start to look, we're about 2 years late launching the first mission. Each technical problem that we've come up against has set us back some. It's taken us the time to go off to solve the problem, primarily because of the fact that the orbiter is such a, I think it's the most sophisticated spacecraft that will ever fly in this decade. And because of the fact that we've taken the state-of-the-art and built that into the orbiter, when we come up against our problems, we certainly got to step back and make sure that we're working out the solution correctly. And these are all setting us back. You know, time is money, and in that respect, yes, every technical problem that we've encountered has delayed us some. But I think we've recovered from that. The tile are behind us. The main engine problem is behind us. I think we're looking to a very realistic launch date.
This launch date, you know, like you said, we're 2 years behind, but that was a date that was established way back in the early 70s, like 71, 72, and they said, yeah, we're going to do this thing in 1978, you know, and with the normal aircraft development procedures or testing, that probably would have been a good timeline, but we're developing a craft here that's way over 50% of new technology, not only with this thermal protection system that you're talking about, but the whole, you know, the engine, the propulsion system is a whole new concept. It's entirely new concept, and things like that. So it's not strange or to me that this thing has slid to where it has.
Wasn't it true? I think during the falling of Skylab about a year and some months ago, I think they said that if the space shuttle had been ready at that time, they would have been able to go up into space, bring Skylab into the cargo hold, and bring it back. There would have been no danger.
When I first joined NASA 2 years ago, one of my collateral duties was on the second mission to help the crew there come up with the procedures to launch the shuttle and attach what we call a space tug to it. And at the time, it wasn't decided whether or not we boosted into a higher orbit and let it stay there for a few more years, or to put the tug on it and bring it down into a known position in the ocean. But of course, the launch stage slid past that, and that mission went away. We all know the consequences of Skylab right now.
Yeah, if it stayed up a few more minutes, it might have come down on us. As it was, though, it went over Australia, and one of the things I think they said was that because NASA was able to wobble it or send out signals to make it turn end over end, it could determine its course. The orbiter also can do something similar in that it can launch satellites into different apogees or perigees or rotations around the Earth. Tell us a little bit about how that can be done, how you can take a satellite, put it in the cargo hold, bring it into space, and then launch it from there.
We have the capability to deploy boosters from the cargo bay of the orbiter. There are two types that we use. One is the solid spinning upper stage being developed by McDonnell Douglas and Huntington Beach. And they come in two models. One is compatible with the Delta missile system. The other is compatible with the Atlas Centaur missile system. The other type of booster that we've got is the inertial upper stage being built by the Air Force through the Boeing company. In both these systems, we eject the payload out of the cargo bay using a spring system. We actually eject the booster and the payload attached out of the cargo bay, and at that time we go through a separation maneuver to get the shuttle away from the payload and the booster. Once we have achieved a safe separation distance, the booster is fired from the ground. It now starts to be commanded from the people on the ground. They fire their boost motors on the boosters and send it into the higher geosynchronous orbits.
And do you have any control of it after that?
Once the payload separates from the orbiter, our only control is to kill the whole system. And it's in a contingency mode. It's for safety only, and that's to take power away from the entire system. In the event that we don't need to do that, all command and control comes from the ground.
I don't know what the ratio is, but it's very much simpler and more economical to launch something, to a higher orbit or to interplanetary things from a low Earth orbit than it is to start initially you're on the ground, like maybe 20 times the ease or whatever. I don't know a good number to put on, but it's very much simpler and more economical to carry it to low Earth orbit and then boost it to a higher orbit from there than it is to start the whole thing from the ground like we have been.
So you could cut your costs, let's say, by 3/4 at least.
You could maybe take 2 satellites up on one mission with 2 boosters, and I can do 2 of them.
We can carry as many as 4 boosters and 4 satellites at one time.
So instead of 4 expendable rockets out of the Cape, then we can take 4 of these up to low Earth orbit, and for 1/20th the cost, get 4 more up to.
Okay.
So it just multiplies itself.
Well, we have about 30 seconds left. Tell me how you both liked Guam. What have you been doing here while you're here, and you're going to come back and see us?
I definitely will be back. I love it. The people have been most cordial to us. They have given us the heartiest welcome we received in any part of the country. The love and friendship they've extended to us have been, we feel to be very sincere, and we hope that we've been able to share some of our space program with the people here in Guam. We certainly, at this time, would like to thank them for all the help, your hospitality, and we look forward to working with you again.
Well, I hope you do come back. And thank you for both being with us. It was a pleasure talking to you, and I'm sure that everybody in America will probably be watching to see how you're doing when your flight comes up. Please
Thank
keep
you.
in contact with us.
Thank you very much.
And that is Island Issues this evening. Thanks for joining us, and also one word of thanks to NASA here on Guam for helping us in the coordination of the astronauts' visits along with Gov Guam and for their shots of the Space Shuttle. I'm Jerry Lyons. Good night, everyone.